Okay guys, today we're going to start learning about how to solve inequalities. Now, inequalities are pretty much the exact same thing as an equation, but instead of an equal sign, you're going to see things like this, like an inequality symbol. So less than, greater than, less than or equal to, greater than or equal to. So again, here's what they look like. This is less than or equal to, greater than, and greater than or equal to. So we are going to talk about how to solve inequalities. So notice at the top of your page in a box it says when solving an inequality, if you multiply or divide both sides by a negative number, you must switch the inequality sign. So just keep that in mind when we start to solve these inequalities. So in number 1, I have d minus 5 is less than or equal to 1. So when we're solving inequalities, we want all of our variables on the left side and all of our constants on the right. This has to happen every single time. The variables have to be on the left side and the constants have to be on the right side. Not like regular equals or equations where you can say x equals 3 or 3 equals x. This one, the variable has to be on the left side. So if we look at number 1, my variable is already on the left side, so I just need to get this minus 5 away from it. So just like normal, we're going to add 5 to each side. Now on the left side, those 5's will cancel out and leave me with d. Now I did not multiply or divide by a negative number, so I'm just going to bring this symbol straight on down, less than or equal to, and then I'm going to take that 1 plus 5 and get 6. Now that I have the variable by itself on the left side of the inequality and the constant by itself on the right side of the inequality, I'm done with my answer. Okay, so two things need to happen now. Now I need to graph my solutions on a number line, and I also need to write my answer in set builder notation. So here's how we do that. First of all, I want to graph my solutions on a number line. So I'm going to start with the number 6. Now, I need to put a dot on top of that number 6, but it depends on my inequality sign on what kind of dot I need to put. So if I have a greater than or a less than symbol, I'm going to use what's called an open dot. But if I use a less than or equal to, or excuse me, a greater than or equal to, or a less than or equal to, I'm going to use a closed dot where it's nice and filled in. And the reason for that is when something is greater than something else, for example, 8 is greater than 7, 8 cannot equal 7. So I would put an open dot there to show that it can't actually equal that number. But if 8 is greater than or equal to 7, we would put a closed dot because we would know that it could also equal 7. So if I look at the sign that I use, I have an inequality symbol that's less than or equal to. Since it's or equal to, we're going to put a closed dot on 6. So I'll start at 6 with a closed dot. Then I need to draw an arrow either to the right or to the left. So if you'll look here, since d is less than or equal to negative or to positive 6, I want to go the direction where the numbers are getting smaller. So if I look on my number line, to the right, 7, 8, 9, 10, my numbers are getting bigger. To the left, 5, 4, 3, 2, they're getting smaller. So my arrow needs to go to the left, and it's going to go all the way to the end of the number line. Now you don't have to make it huge, but make it thick enough that we can see it. Then we're going to end it with an arrow to show that it's going on forever in that direction. So here's what this means. Any number on my number line that is underneath this arrow, so 5, 1, negative 3, any of those numbers would work for this inequality. For example, if I chose 2, 2 minus 5 is less than or equal to 1. So 2 minus 5 is negative 3, and negative 3 is definitely less than or equal to 1. So all of those numbers work. Now finally, I need to write my answer in what we call set builder notation. It's how we write our answers for any inequality. So here's what we do. We start with a set bracket. Then we write the variable that we're using. So in this problem, we're using a d. Then we draw a nice, tall, straight line. Then we write our answer. d less than or equal to 6. And close our set bracket. So here's what this answer reads. It says the set of all d's such that d is less than or equal to 6. So here's what this means. I can choose any number for my answer d such that d has to be less than or equal to 6. So it's saying I could have any number that I could put in there, but that number has to either be less than or equal to 6. Let's try it again on number 2. I want to solve for t. The variable needs to be on the left side. The constants need to be on the right. So the variable's already on the left side, which is good news. Now let's subtract 9 from each side to get the constants over to the right. So these 9's cancel out and bring me down t. Now I did not multiply or divide by a negative number, so the sign stays the same. It's going to stay pointing to the left. Now I'm going to take 8 minus 9, and I'm going to get negative 1. Next, all we have to do is graph it. So, less than negative 1. I'm going to find negative 1 right here, but since it's less than, not less than or equal to, we need to put an open dot. So we're just going to put an open dot there and not fill it in. Now, I want numbers that are less than negative 1. So if I look at my number line, the numbers that are smaller than negative 1 are going to the left. So here, my arrow is going to go to the left. So all the way to the end of the number line, put an arrow to show that it goes on forever and ever. And then finally, we need to write our answer in set builder notation. So the set of all, and we have t's, then our tall straight line that represents such that, then our answer, t is less than negative 1. So again, the set of all t's such that t is less than negative 1. Number 3, I have negative 2b plus 4 is greater than negative 6. So again, I want all the variables on the left side, all the constants on to the right. So I'm going to start by solving for b by subtracting 4 from each side. Now on the left side, the 4's cancel out and leave me with negative 2b. I did not multiply or divide by a negative number, so my sign stays the same. And then negative 6 minus 4 is negative 10. Next, to get b by itself, we're going to divide each term by a negative 2. Now here's what we're going to do. We're going to do the math first, and then we're going to worry about the sign. So negative 2b divided by negative 2 is just a positive b, and then negative 10 divided by negative 2 is a positive 5. Notice I divided by a negative number. When that happens, we need to switch our inequality sign. So here it's pointing to the right. Now I need to make it point to the left. So instead of greater than, it's less than. So I get the result of b is less than 5. So let's graph it. So I'm going to find 5 on my number line right here. And since it's less than, it's going to be an open dot. And less than means it's going to go to the left because the numbers are getting smaller as we go to the left. So my arrow needs to go all the way to the end, thick enough to see it, and end with an arrow here. And finally, we need to write our answer in set builder notation. So we have the set of all b's such that b is less than 5. Alright, what I'd like you to do now is pause the video and do number 4 on your own. Alright, hopefully you subtracted 15 from each side, and you got 3x is less than or equal to 6. Then you divided each term by 3, and x is less than or equal to 2, which means it is a closed dot on 2 with an arrow going to the left. Now, to write that in set builder notation, that's the set of all x's such that x is less than or equal to 2. Alright, on number 5, again I want to solve for d, so I'm going to add 1 to each side. And we're going to be left with d over 2 is greater than or equal to 4. Now to solve for d, I want to get rid of this divided by 2, so I'm going to multiply each side by a 2. and d divided by 2 times 2 is just d. 4 times 2 is 8. Now, even though we multiplied each side by a number, it wasn't negative, so the sign stays the same. So d is greater than or equal to 8. So I'm going to find 8, and since it's greater than or equal to, it's going to be a closed dot. And then greater than means I want the numbers bigger than 8. So if I go to the left, 7, 6, 5, 4, the numbers are getting smaller, which means I need to go to the right, all the way to the end, with an arrow. And then we have set builder notation. So the set of all d's such that d is greater than or equal to 8. Alright, on number 6, I want to solve for f. So I'm going to start by subtracting 3 from each side. So this is really no different than solving for an actual equation. So I have negative 2/3 f is less than negative 12. Then I want to get this negative 2/3 away from the f. Now remember, we do not divide by fractions. Instead, we multiply by the reciprocal. So I'm going to multiply each side by the reciprocal, which is negative 3/2. And over on the left side, it'll cancel out and leave me with f. On the right side, I'll have a negative times a negative, which is a positive, and then 12 times 2/3. So I'm going to start with this denominator. 2 goes into 12 6 times. 6 times 3 is 18. Now, I multiplied each side by a negative number, so now my inequality sign switches, and instead of less than, it is greater than. So I have f is greater than 18. Now, to graph it, I'm going to start at 18, and since it's greater than, it's going to be an open dot. And then greater than means I want the numbers that are bigger than 18. So if I go to the left, 17, 16, 15, 14, those are getting smaller. If I go to the right, 18, 19, 20, those are getting bigger. So I'm getting bigger. I'm going to the right, and I end it with an arrow. On number 7, notice we have a variable on each side, and that's okay, but what's important is that our variables end up on the left side and our constants end up to the right. So even though, like, logically you're like, oh, I should move the 2p over because then it would be a positive. I understand that, but our goal is to get it on the left side. So let's instead subtract 3p from each side. And when I do that, I'm going to get negative p plus 5 is greater than or equal to negative 10. Then I can subtract 5 from each side, and I'm left with negative p is greater than or equal to negative 15. Then I need to make this positive, so I'm going to divide each term by negative 1. And oh, I divided by a negative, so my symbol is going to switch. So p is now less than or equal to positive 15. Now to graph that, I'm going to go to positive 15. Put a closed dot because it's less than or equal to, and my arrow is going to go towards the smaller numbers. So 16, 17, 18, that's not the way I want to go. 14, 13, 12, I want to go to the left. And end it with an arrow. Finally, we read our answer in set builder notation. So the set of all p's such that p is less than or equal to 15. And now that I think about it, I don't think we did set builder notation on number 6, so let's go back and write that one quick. This one should be the set of all f's right here such that f is greater than 18. On number 8, I have negative 6 times the quantity of w plus 1 is less than 2 times the quantity of w plus 5. Not a big deal. Let's start by distributing. So I'll have negative 6w minus 6 is less than 2w plus 10. Now we did not switch the sign yet because we just distributed. So even though I multiplied by a negative, I didn't multiply the entire equation by a negative. So here, to solve for w, I want all the variables on the left side, all the constants onto the right. So I'm going to start by subtracting 2w from each side. Or if we were to think, negative 6 minus 2 is going to give us a negative 8w minus 6 is less than 10. Then we're going to add 6 to each side, and I'll be left with negative 8w is less than 16. Divide each term by a negative 8. So when I divide by a negative, my symbol will switch sides, so I'll have w is greater than a negative 2. Now to graph, since it's greater and not greater than or equal to, it's going to be an open dot on negative 2. And I want the arrow going the direction of the numbers that are getting bigger. So if I look at my number line, they're getting bigger as I go to the right. So my arrow is going to go to the right. Make sure it's thick enough that we can see all the way to the end of the number line and end it with an arrow. Now on the back side, we're going to do some word problems for inequalities. Now inequality word problems are similar to equation word problems. The only thing that's different is the inequality symbol instead of an equal sign. So the first thing that we need to look for is the term that represents the inequality symbol. So it says 4 more than the quotient of a number in 3 is at least 9. Now the term or the phrase that's going to represent the inequality symbol is always going to follow the word is. So if I read it again, 4 more than the quotient of a number in 3 is at least 9. So here's the word is, and it's followed by at least. Let's put a box around that phrase right there. That phrase right there represents my inequality symbol. Now we have to figure out what symbol they want. So is at least. If I were to say that you would qualify to go to college as long as you were at least 17 and you were 18, you would still be able to go to college because you were at least 17. So at least means you have to be that age or that number or more. So if I say you had to be at least 17 to get into college, and you say, well, hold on, I'm 17 years old. Can you go to college? Absolutely. Say, well, wait a minute, I'm 18 years old. Can I go to college? Absolutely. Well, I would say, well, hold on, I'm 26 years old. Can I go to college? Absolutely. What if you were 95 years old? Could you go to college? Absolutely. So is at least means you have to be that number or bigger. So the symbol to represent at least is greater than or equal to. So let's put that above that, greater than or equal to. Now on the left side of that symbol, we have 4 more than the quotient of a number in 3. Now remember, more than is the phrase, like more than and less than. It is not representing a symbol because it's not is more than or is less than. It's just more than or less than. And that means that went on at the end. So 4 more than means we're going to tack a plus 4 at the end of this side. Then it says the quotient of some number and 3. Now I don't know what that number is, so I'm just going to call it x. But quotient represented division. That was one that we struggled with sometimes. So I want 4 more than the division of x and 3. And then on the right hand side, we just have 9. So let's write our inequality. I want to start with that x divided by 3. So x over 3 plus 4 is at least, so greater than or equal to, 9. Now all we have to do is solve. So I can subtract 4 from each side, and I'm left with x over 3 is greater than or equal to 5. I can multiply each side by 3, and I'm going to be left with x is greater than or equal to 15. Number 10, the sum of a number and 14 is less than or equal to 3 times the number. So remember, the phrase that represents the inequality symbol follows the word is. So here we have is less than or equal to. So this one's pretty straightforward. It tells you exactly what symbol to use, the less than or equal to symbol. Now it says the sum, so we're going to be adding a number, so I'm going to call it x, and 14. So I'm going to be adding x and 14, and that's going to be less than or equal to 3 times the original number that we already chose, which is x, so 3 times x. Now we need to solve. Remember, I need to get all of my variables onto the left side and all of my constants onto the right. So I'm going to start by subtracting 3x from each side. And x minus 3x gives me negative 2x plus 14 is less than or equal to, and on the right side they cancel out and leave me with 0. Then I can subtract 14 from each side, and I get negative 2x is less than or equal to negative 14. Divide each side by a negative 2, and hold up, we divided by a negative, so now we have to switch which way the symbol is going. So x is now going to be greater than or equal to positive 7. On number 11, we have 5 times a number decreased by 8 is at most, so that's the phrase that we're going to look at for our inequality symbol, is at most 10 more than twice the number. So let's talk about what is at most means. For example, if you go to McDonald's, you can get a kid's meal if you are at most 12 years old. Okay, so you can get a kid's meal if you are at most 12 years old. So for me, I am 26. I cannot get a kid's meal because I am not at most 12. If I were 12 years old, I could still get a kid's meal. If I were 8 years old, I could get a kid's meal. If I were 6 years old, I can get a kid's meal. So is at most means you have to be less than or equal to that number. So is at most represents less than or equal to. Now on the left side, I have 5 times a number, so that's going to be 5x, decreased by minus 8. It's less than or equal to 10 more than, so remember more than means it goes at the end, so plus 10, twice the number. Now twice the number means we're multiplying that number by 2. So you should have 5x minus 8 is less than or equal to 2x plus 10. Now we need to get all of our variables onto the left side and all of our constants onto the right. So go ahead and pause the video and solve this inequality. So hopefully you subtracted 2x from each side and got 3x minus 8 is less than or equal to 10. Added 8 to each side and get 3x is less than or equal to 18. Divide each side by 3 and x is less than or equal to 6. On number 12, 7 more than 5/6 of a number is more than negative 3. So remember, more than means plus at the end. Is more than represents our symbol. So is more than is just going to be a very basic greater than symbol. 7 more than means we're adding 7 to the end. 5/6, so that's a fraction, 5 over 6, of a number. So that means I'm going to take that 5/6 times x, and it's greater than, so 5/6 x plus 7 is greater than negative 3. Now again, I'd like you to pause the video and solve this problem. Alright, so if you subtract 7 from each side and multiply each side by 6 over 5, you get x is greater than negative 12.